Hello, and my name is Nate Nesler. This is for Hyperactive Studios, and we've been doing SDL and OpenGL. And basically what we're going to do in this video is we're going to take our same project from before, and we're going to tweak it a bit, and we're going to add joystick control capabilities to it, along with direct joystick access control, and also do direct mouse control instead of a polling event system for the mouse. And so basically we can take the same code and we can just make these variations. Now you notice that the code is basically the same except for this right here. Now we're going to add in include here and #include space open close greater than less than signs vector here, and then #include greater than less than sign string, and #include greater than less than math.h. Now this is important. A vector here is going to be used for taking in a list of controllers. You could also use a list one instead of a vector inside of C++ if you wanted to for standard lib, but standard library, standard lib, same thing. STD is another way of putting it. Stands for standard. And then we also going to have string here. Now we do need string for a variety of reasons. We'll go over that in just a bit here. And then we'll need math in order to help do some of the joystick logic. And I'll go into why you want to do a certain setup or whatever. And then you can control that if you like. And we'll get into talking about calibration of joysticks and things of this nature. And the way I've written this code where it auto detects the controllers, finds out how many buttons there are, all the axes, gets all the information for the controllers. And then they're ready to be made available to be used inside of a configuration screen for the player, where they could set up and configure their controller and assign, through binding, different types of actions to certain particular parts of the controller. So, first and foremost, let's look at what we need to do in order to make this happen. Now, I've done a few things. You may notice something different. I did do a const here, and I did it as a unsigned int 8. Alright, so there's SDL has its own data types, just like OpenGL does, and that's again to make it work across all the different platforms. In this case, a uint8 is going to be an unsigned, 8-bit data type. And so our left mouse button is equal to 1, semicolon here, because that's the exact same data type that's used for the mouse button number here. It's a unsigned int8 SDL data type. Same thing here goes for the middle mouse button and the right mouse button. So I have these different names and their constants here. If you want, you can do yours in all caps. That's also typical of doing constants, is to do the entire word as all caps. You might do underscores separating the different parts so it's more readable, and that's totally fine too. Also, we have a unsigned int 8 here for our mouse ABS state here. I'm going to say that it's equal to null for now, semicolon. And null is only possible with int type data type. Unsigned int here 8, and that's going to be our mouse rel state here, and that's equal to null also, semicolon. And then we're going to have our int mouse ABSX equals 0, int mouse ABSY equals 0, int mouse rel x equals 0. Semicolon there, and then int mouse rel y equals 0, semicolon. And the reason for this is these are going to be the actual positional values for our absolute position in x, absolute position in y, our relative position in x, and our relative position in y with the mouse for where it is pointing on the mouse cursor on the screen. Okay, so const float rotate x underscore speed equals 0.5 f, semicolon. Const float space rotate y underscore speed equals 0.5 f, and then const float zoom speed equals 0.1 f here, semicolon. And this is cool because in this way we can actually use this to control the speed of the zoom. And that reminds me, okay, I'll copy this to use it later, because I'll need that. I'll have to change something around. I forgot to change out the 1.0 with this actual variable here for a constant, so I'll do that in a bit. Okay, and then we have our GL float for rotate X. This is what actually rotates. Now this is nothing new. This is identical to the previous program, so you shouldn't have to change any of that. This is new also. Uint 8 here, star key state. Well, I think this is new. This may not be new. Key state equals null semicolon. That might not be new. Int key delay equals 1 semicolon. Int key repeat equals 10. No, that's got to be the same as last time. I'm not going to go over the keyboard because I didn't change anything on the keyboard. The keyboard is identical to the previous setup. SDL underscore joystick star joystick semicolon. Alright, this lets us create a joystick, as you would imagine. And this is the SDL data type for a joystick. Int numb joysticks equals 0 semicolon. This lets me store the number of joysticks that are currently attached to the system as a number. And I'm just having that set up. I will actually use a command from SDL to find out what that number is and assign it to this variable. And then I can easily just pass that value through my struct, my data structure. Okay, let's do some structs. And these structs come from C, and it makes it really tight and confined for doing for purring out these. Let's organize our variables into sets, right? So that it makes sense, so you can easily manipulate it. And then, but this uses the minimum amount of memory that's needed in order to do it. So that's what's so attractive about the C struct versus doing it as a class. Yes, I know we could write this up as a C++ class. It's going to be slower and it's going to eat up more memory. So we don't want to do that. This is very typical of game programming, where we'll intermix C struct styles along with classes. And I know some C++ purists will be very upset about this because it doesn't match the memory configuration layout of C++ throughout everywhere in C++, so you don't have a total memory match of everything. Because we're dealing with totally different data types between C and C++. I understand all that. However, we're most concerned about speed, and we're concerned about how much memory is being used in the system while we're running our game. Otherwise, we can't do as good at graphics, and we also can't load as much things. So you're going to be talking about an uglier game that can't run as fast, basically. That's slower. I mean, that's not acceptable in the game industry. So we do have to have an application that's performance, based, and it does need to actually look good and be able to perform well. So that's very important. It's a very key stipulation of game development. So it needs to be very interactive too. If we bog it down with a whole bunch of, hey, we can sit there and add some, heavy into garbage collection and all this stuff. But if you start doing that kind of thing, you're going to bog it down even further and even worse. So, again, try to take every shortcut you can possibly take in game programming to keep things fast. But anyways, so struct here, I'm going to call my struct it becomes a data type basically. And it's going to be called joy ball here because this gets into the ball of the joystick for those joysticks that have balls on them. Believe it or not. My joystick doesn't have any balls, but apparently some other people do. I'm using a game controller pad from Logitech, which is really great. And you might want to check out Logitech's website on that, and I'll pull it up here in a bit. The great thing about Logitech's, and I'm not being told, but I don't have any connection to Logitech at all. I'm not having anything. This is my own opinion on it. Logitech has game controllers that closely mimic that of the Xbox 360 and PS3. So if you program out for one of their game controller pads, and they're quite cheap too, by the way, they're a lot cheaper than the ones for Xbox 360 and PS3. So you can get one of them. They work for your PC games. They work beautifully. They feel really great in your hands. They perform very well in your game tests. And then when you program out for one of these, you basically programmed out for like the PS3 controller or the Xbox 360 controller. So that means when you go to port the game to those platforms, it won't be much of a, won't be much effort to make it port over, because you're handling that with the, you're already handling that as far as the game controller programming goes. So it makes things go easy and nice indeed. Okay, so here's the joy ball, and it's going to have an X and Y position. And that's it for that struct. And then we always end it, and that's open close curly braces, and we always end our struct with a semicolon at the end. This is easily missed by someone who's new to this, so make sure you put that semicolon at the end. It's hard to remember sometimes because you don't use structs all that often, but you know, when you do use them, make sure you put that semicolon there. Otherwise it's wrong and doesn't work, and it's sometimes a hard bug to hunt down and find. Struct here space joy control. So this is going to actually be our joystick controller, and these are all the attributes of our joystick controller that would go together. So I'll put them all together in a handy dandy to use struct. Thankfully we can intermix our C++, STD libraries even, and class structure for our data types with inside of a struct from C. So that's great. So open my curly brace here, std : so I'm scoping out. Yes, I know I could use using namespace std at the top, semicolon at the top, but it's better programming to have std : here and actually scope all your programming commands, so that way you don't have name collisions between different names from different systems. And since we're going to be including all these different libraries, this is standard best method to work by, and this helps reduce errors. So I'm not using std commands all that often in here, so it's not that bad. So std : string here for the string data type, space name for the name of the controller, semicolon. So this gives me the name of the controller. Int here, num axes, semicolon. So this is going to tell me how many, I'm going to store the number of joysticks, or shall we say, yeah, basically like the sticks that you move around on your joystick controller. This could be your main joystick itself. If on a gamepad, you got your little sticks that stick up, your joysticks that stick up on your game controller pad, and each one of those would be a axes. Also, if you have some of those joysticks that have some of these game controller pads have little trigger buttons on the back, each one of them are also considered axes. And the reason why is that they have a full range of motion there. So for anything that has a full range of motion, is actually going to come up as an axis, if you will, an axis controller, or a stick, a joystick, basically. It's considered the same thing. Because from a programming standpoint, it may only move on the x-axis or something like that, for your triggers. So that's fine. Whereas, your joystick's going to move on the x and y axis. But this gives you access to those triggers, so that way you can do a range of actions. That's really great for doing gunfire or something like that, right? Because then you can control just how you can go from burst fire to single fire to full auto fire based on how far someone's pulled that trigger button on the back of that controller there. And the Logitech controllers have those trigger buttons on the back, which is really nice. So if you want to practice programming out for those, because they have them on the Xbox 360 and PS3, then you can get one of those Logitech controllers, like I said, and program out for it, and they're very reasonably priced. Far more so, usually about half the price of what they are for Xbox 360 or PS3. So that's very nice, and lets you do your game programming for less money. Alright, numb buttons, semicolon here, and this is the number of buttons on your controller. They're going to be stored here. Int num hats for the number of hats that are on your button. You'll see the hat at the top of a joystick controller. It's the little button that's multi-directional on there. On my, I have a hat also on my game controller here, gamepad controller, and it's the multi-directional gamepad that you press with your thumb here. That is considered the hat on it, and it has 8 different positions: up, down, left, right, and those are based on numbers, and then other numbers for the directionals here. So it gives you like 6, 7, 8. It'd be your odd numbers. So it's like, I'll pull it up sometime and show you guys. But we'll just do that sometime when we code it out for making the gamepad do different actions on the joystick here. But yeah, basically it's based on numbers. You got your main chord numbers here, like 1, 2, 3, 4, here for your top, bottom, left, right here, and then your diagonals of 6, 7, 8, 5, 6, 7, 8. Sorry, would be your diagonals. whereas combination of 1 and 4, for instance, would be like 5, or so on and so forth. So that's very cool. Okay. So with that, that's hats, and then here's the number of balls you may have on your joystick or your controller. I don't have a ball on. I don't have any balls at all on my controller, gamepad controller. So that's not going to be something I'll be able to show off in this video. But if you do have them, here it's programmed out for it, and I've already coded it out for them. I just have no way of testing it. STD : vector here, open and close greater than, less than signs, signed integer 16-bit here, and we need that for our axis here. Okay, so it's for our axis. So if we have an XY axis, then they'd be stored in there. If we have just x-axis, then it'd just be stored x-axis in there, etc. So on and so forth, depending on however many axes some device may have. Some device may have, more than that. Maybe they have 3 axes or something like that. X, Y, Z. It is possible to have that. There are some sticks out there that have, forward, back, left, right, twist it. You can literally twist the actual stick itself, and then you can move it up and down even. So then you have like 6 axes of, would it be 6 or be 5? That'd be 5. 5 axes of direction. That's quite a bit. So for a single joystick, yeah, it's quite a bit. So be aware of that, because those actually add extra rotation axes there. Your joysticks may have side-to-side rotation on them also. Tend not to go up and down though. Their 3D Connects has one that goes up and down, in addition to rotating side to side and moving forward and back and all that. So very cool, and be aware of that. STD : vector, open close greater than less than signs, unsigned int 8, and then that's for a button. So this is for our button presses. Now remember, we had our buttons on our mouse were the same type, data type. So it's the same thing for the joystick too. Okay. STD : vector here, open close greater than less than signs, unsigned int 8, and this is for our hats, so that way we can store each of the hats in there. So we know the number of them and store all of the hats in here too. STD : here, vector, greater than less than signs, joy ball here, and then subtype for the data type here for struct, and it's going to be called ball. And this is going to handle all our joy balls for our X and Y's here. So it's very cool, and it makes our lives easier by far by having this. And so with these vectors here, we can store all these different attributes of each joystick, knowing everything from the name of the joystick to all the number of buttons, axes, hats, balls here. Typically you don't have more than one hat or ball on a joystick, but if you do, here they are. And you can do it, you can get more than one, and then be able to access all that information with inside that joystick structure, all in one here. Close curly brace, semicolon. And so that gives us as one data type every attribute basically of our joystick controller that's available to us inside of SDL. Okay. We don't have access to rumble, unfortunately, and we don't have access to, well, I don't know if we have access to our 6-axis or not. We may or may not, I don't know. I've never tried playing in a 6-axis controller into the computer and seeing what we get. So maybe that's available, maybe not. I don't know. But I know we don't have access to rumble or force feedback. So, unfortunately. Okay. STD : vector, open, close, greater than less than signs, joy control here, and then we're going to have joysticks, semicolon. So now I'm creating a vector of joysticks. If you want to think of a vector, if you're not familiar with a vector is like a resizable array. Basically, we can add and remove items from the array. We can, from this vector, on the fly during runtime. We can resize our array at any point in time. So that's the problem with array. With an array, you need to know what the size it's going to be ahead of time as a fixed size before you ever allocate or use it. And at any point in time during the execution of the program, you cannot extend it or expand it or add anything to it. the positive thing about an array, so now you're probably going, well, if we have vectors in these lists, why would we ever use an array? Well, a vector and a list have a lot more overhead in memory. So for that reason, you would still want to use arrays. If you know ahead of time what the size of something is going to be, and you know you're not going to change it later on, then you're way better off to use an array because it's going to use less memory and less RAM. So it makes a lot more sense to use an array in those circumstances. But if you have a situation where it could change dynamically during the execution or actions of the game or something like that, then you need to be using a vector or a list to handle that. In the case of the joysticks, someone could plug in a joystick while we're playing the game, right, and activate the joystick during gameplay. So if that happens, we need to be able to detect that joystick, and we need to be able to add that joystick to our structure. So obviously an array is not going to work. Well, if someone plugs in the joystick after they start the game, well, that's not going to work either, because if we initialize the controller at the beginning, we create our array, then we'll have it as no joysticks are part of the system, and someone will have to literally shut down the game in order to plug in their joystick, and we don't want that. So we want it to where it can be dynamically added on the fly during gameplay. So for this reason, I've coded it where joysticks can be added later on or whatnot, and we can just add them to our vector list, and it's not going to be a problem with our structure here. Alright. Don't want this in here. Okay. Alrighty. So we have everything else is the same. I don't want that in there. We'll get into doing a FPS setup later. Alright. Draw scene. This lets us draw our scene here. GL clear here. Open parentheses, GL underscore color underscore buffer underscore bit. This is all the same. Starting to think about it. This is all the same. I don't need to go over this. Same thing for keyboard. Nothing's changed here. We have it to where if you hold down the key, it does automatic repeating of that key within inside SDL. And this is really nice because we can set up our key delay and our repeat, which is great. Our mouse, direct access of our mouse. Okay, so this is where I was talking about I needed to swap out that value. So there's the zoom speed. And it does work fine. Just hold that up here. You'll notice that we can zoom in and out just fine. And rotate with our mouse, no problem. Okay. Alright, so void mouse and open close parentheses void here, open curly brace, mouse abs state here, so absolute value state is equal to SDL underscore get mouse state, open parentheses, and mouse ABS X, comma, and mouse ABS Y, close parentheses, semicolon. Okay, so first off, the mouse ABS state here is what it's going to, this get mouse is going to assign that to our mouse ABS state. Now, if you looked at our mouse ABS state, was up here, and you can see it's an unsigned int. So we're going to know what the status is of that state. The reason we are passing in our referenced value of our mouse ABS X and our reference value of our mouse ABS Y is because these values are going to get set within inside of this function from SDL. Basically, these values will end up with the X value here and the Y value being stored in these variables in memory when this function is done, and then it replies with its actual state of execution here. So if we had a state here, we can find out what the state was. Was it left mouse button? Was it right mouse button? Was it, et cetera, et cetera, et cetera. Was it 1? Was it 3? Was it, what was it? So we've set up these consts here so we know what button it was that was pressed. It's being replied. And it's the same for relative state and absolute state. So if it replies with a 1, that means left mouse button was pressed. If it replies with like a 2, then that would be middle mouse button. If it replies with 3, it would be right mouse button. Hopefully. Maybe not always. In my case, for my mouse, I ended up having to put a 4 here, which sounds strange, but that's what it ended up coming out as. How I found that out was through my Fprintf, with having it actually output that to the file, so I could find out what the actual value was. You can see here what I did with my absolute X, Y, and absolute state here. And it let me see what button was actually being, registered as the right mouse button for absolute state. And for whatever reason, mine came out as 4. So, another reason why you'd want to be able to have this set up in a configuration window for your game. Because who knows what your value is going to be for your right mouse button or for some button. This particular mouse has got 5 buttons on it, and then it also has a mouse wheel. So you have to take that into effect too. And then actually it's got 6. Looking at it, it's got 6 buttons on it. So this is a non-standard mouse. It's a little over the top, if you will, of extra functionality here. So be aware of that. My mouse is different than the normal mouse, the normal 3-button mouse. But that's becoming more and more common too. So we'll see how things go. Okay. So with this mouse state, we know which button was pressed, and then this gives us the location at where the mouse was when the mouse button was being pressed, basically. So I have if, open parentheses, mouse rel state is equivalent to left mouse button, which remember is the value of 1, close parentheses, open curly brace here, rotate x plus equals mouse rel y, right, because that's what it returned with for the values here, times 0.5 here. And we have our zoom speed here, and honestly, hold on, let me just jump back up here real quick. I'm so sorry, but I need to check out, I think I had a value here to deal with the speed. I did have a value for the speed. That's what I thought. Yeah, I need to use it. Alright, yeah, that sounds like something I would do. Alright, and I just totally forgot to use this. Alright, so now we got a constant speed here value. Now I could change that from a constant to, I think it's constant. Let's see here. Is it a constant? Where is it? Yeah, it's being set as a constant now. But if you were doing this inside of a game for an editor window, you may not want this to be a constant. You may want this to be able to be changed and edited so that the speed could be altered or tweaked on the actual mouse. Okay. So, and then we'll just do one more check here real quick, but it should work fine. It does. Didn't expect any problems with that. Okay, cool. Okay. So that sets up our rotation speed here as a constant value. We can just change it at the top. And everywhere there's a mouse speed, or this will get updated accordingly everywhere in the code. So that's why you want to use constants, because it makes it easy to change the value in one place and it updates everywhere. That's the idea. And just also it's descriptive, so we know exactly what this does. This changes the speed of the x axis here, and this changes the speed of the y here. So for y rotation. Oh no, I need to switch this around, because this is for x here and this one's for the y, for speed of rotation. Alright, so semicolon there, close curly brace. If open parentheses mouse rel state equals right mouse button, which is going to be 4 in our case, well, for my case, for me. For you it might be a different value, but you set that up in your constant up at the top of the program. Close parentheses, open curly brace, zoom minus equals, for the same reason I gave last week, mouse rel not last week, but last video, mouse rel y times zoom speed here, semicolon. And so this is going to determine the speed at which we zoom in and out, which is 0.1, and then our mouse relative position, and then of course minus equals zoom. Okay, and then this was the Fprintf statement that I used right here. You can see it goes across the whole window here. Fprintf open parentheses stdout comma quotes mouse absolute button %d pressed at open parentheses %d comma %d close parentheses /n close quotes comma, and then mouse abs state comma mouse abs x comma mouse abs y close parentheses semicolon, and that output the value to the file for standard out to see what mouse button it was for pressing the right mouse button. If you don't know what it is that you're getting for your right mouse button, please uncomment this and then save, and then when you press the right mouse button, it will actually go to your standard out std file inside your bin. Let me show you where that is again. Okay, wrong window. Alright, so in the case of our program I set up another program and I called it key mouse joy here, OpenGL. Alright, inside of debug, here's our standard out, and we can see it getting some of the values in there. So this stdout file is where it's going to appear, and this is what where the values are going to get stored here for your right mouse clicks. Oh yeah, I formatted it so it's nice and pretty every time we do a joystick reading, if you will. Okay. So that sets this up for our mouse here. Close curly brace here. Okay. And our joystick is more involved, to put it nicely. Alrighty. So let's initialize our joystick first. So void init joystick open close parentheses void inside. Open curly brace here. So this is just to initialize our joystick. Numb joysticks equals SDL underscore numb joysticks close parentheses semicolon. This gets us the number of joysticks that are attached to the system currently when this function is ran. So anytime we run this function, we'll get the number of joysticks and we'll get all the information on those joysticks. So this means we can just init joystick any point in time we need to. So say if we have a menu come up or whatever, and we have our users go configure it, however, for a configuration thing, we can also run init joystick again in order to get the values for the joysticks and see if another one's been connected to the system since then. So that's always that would always be useful and nice for a configuration window, because you figure after someone attaches a new joystick, they'll probably go to configuration window if they're doing this for the first time. Okay. So that and we say I do a check here. So I say if numb joysticks is equivalent to 0 close parentheses, then Fprintf standard out no joysticks found. Now we don't have to do this to Fprintf if you don't want to. I just did that so that we know that there's no joysticks found. If you're doing this in an actual live game, I wouldn't bother. I would just basically ignore this part here. Else, so if there are more than 0 joysticks, curly brace, joysticks.resize, open parentheses, numb joysticks, close parentheses, semicolon. So I'm resizing the number of joysticks here for my vector, for basically think of it like the array, the size of the array, to the number of joysticks that we have. So that way I have a vector for every joystick there is of type joystick that we set up. Joy control. For int, index equals 0, semicolon. Index is less than numb joysticks, semicolon. So basically we're going to go from 0 to the up to the number of joysticks there are. This keeps us around to do numb joysticks -1 here, because I just said less than instead of saying less than equal to. This makes it easier, I think. Index ++ here, close parentheses. So this is going to let us go through every joystick. And so basically we're going to start filling in the values for every joystick, getting the information from SDL for the information for our joysticks. So hereafter we can just use this information to do configurations or to interact with different things, so we know to loop through all the different buttons or whatever attributes for each controller and handle it on a controller by controller basis. So very cool. This makes our program more dynamic and more useful. So open curly brace here, joysticks, open brackets here, index.name. So we're going to assign the name for each joystick in the system. So equals SDL underscore joystick name here, open close parentheses, index inside there, semicolon. So here we're saying for the first joystick, get the first name for the first joystick, and assign that to our name for our first joystick. There we go. And so on and so forth for each joystick as we loop through. Fprintf here, stdout, comma, in quotes, name of joystick. Here, so I'm saying the name of the joystick to be outputted to the file. This is for testing purposes. Of course, you just comment this out for actual release. For actual final release, you probably just remove this altogether. But comma here, SDL underscore joystick name here, open close parentheses index here, close parentheses semicolon. And then this is important. After this command, after we get the name, we then have to open our joystick. Okay, that is key, because if we don't open our joystick, we don't access it. If we don't access it, we can't get all this information that we need for it. So this is, think of this as like a GL begin and GL end in OpenGL, but this is for SDL, and so this is for our actual joystick. So SDL underscore joystick open index here, semicolon, and it's going to reply with the joystick itself. Okay, so we need that, so that way we can get the attributes of this joystick. So here we are, we're opening that joystick and it's passing back a value for our joystick as to the joystick we opened. So SDL underscore joystick event state here, open parentheses, SDL underscore enable, close parentheses, semicolon. So another thing that's key, we have to actually enable the event state on the joystick. If we don't do this, we can't get any events for the joystick. They actually have to be turned on. So that's also very important and very key also. So make sure you do that, because if you don't, then it's not going to work. There's a lot of things you got to do. You have to open it, you have to turn it on, you have to, basically, if you don't do all this stuff, it won't work. It's a lot of fun to figure out and find around, because I didn't find hardly any documentation that tell me what to do. Figured out this stuff mostly through the School of Hard Knocks. Joysticks here, open bracket index close bracket dot numb axes here, and this equals for the number of axes SDL underscore joystick numb axes open parentheses joystick close parentheses semicolon, and this is the special command that gets the number of axes or axis on our joystick. Think of it as the controller sticks on the controller, the number of those. This could also again be the throttle, type controls where you got the buttons, the trigger type buttons on your game controller. Something like that would be an example of it. I've seen some other ones too where I have like a slider on one of my joysticks, flight joysticks. So I'm gonna have a little slider on the side here for doing my throttle, for how fast I'm moving in the plane. That's another example of an axis, even though it's not the actual stick itself. So that would also be an axis. Okay, so joysticks, open bracket, index, close bracket, dot axes, dot resize, open parentheses, joysticks, index, dot numb axes, close parentheses, semicolon. Okay, so we have the number of axes assigned, and we're going to use the number of axes to resize our vector to the number of axes that exist on this particular joystick. So this way we have the number of axes to be able to be stored into our vector. So that way we can have values for each axis on our joystick, which makes sense. Axis here, dot resize. Fprintf here, standard out, number of axes. Again, I'm doing this for testing purposes. %d here, /n, close quotes, comma, joysticks, open bracket, index, close bracket, dot, numb axes, close parentheses, semicolon. Alright, and that displays the number of axes. And if you're having a hard time remembering where that came from, here it is. Number of axes. In my case, I got 4. So, be aware of that. X, Y, X, Y for each set here of joysticks.